In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. Are there planets beyond our solar system? It's a question few had dared to probe.
The origin of hunting for planets started really from the lunatic fringe of science.
Now hundreds of these exotic worlds have been found. Could any of them be home to alien life?
Right now, the sort of planets we're discovering are kind of monsters.
You would be incinerated immediately before you had a chance to really sort of groove on your surroundings.
But some planets hold more promise.
I'm so excited about Gliese 436, I'm almost jumping out of my clothes.
Could we be on the verge of finding another Earth?
We still don't know whether our Earth is a commonly occurring planet or a 1 in a billion freak.
Cutting-edge science, strange worlds, and wild weather as we travel the universe in search of alien planets. Lurking in the constellation Pegasus, 50 light-years from Earth, is a monstrous planet. A superheated gas giant almost as massive as Jupiter, whipping around its star in a little over 4 days. It's called 51 Pegasi b, and in 1995, it became the first planet detected orbiting an alien sun. It was a landmark discovery, but just a stepping stone on an even greater quest to find a planet that looks more like our own. The ultimate but elusive goal for astronomers is to find another Earth.
What we're after is the appreciation of where our Earth fits in the grand context of our universe, and we'd love to be able to find other Earths. But Earths are so undetectable, little chunks of rock that don't emit much light.
How common might Earth-like planets be in the universe? Even if only 1% of all stars were circled by a planet like our own, that would still mean there are billions of other Earths waiting to be discovered.
We are almost sure that rocky Earth-like planets exist in abundance out there. But how Earth-like? There are still open questions about the uniqueness of our Earth. And we don't know whether our Earth is unusual or not. It's an extremely profound and, I think, disturbing question.
In the realm of alien planets, there's a wide range of imaginable worlds. We might find ocean worlds, completely covered in water. Frigid ice planets. Mars-like worlds, but perhaps with thick atmospheres, fed by massive active volcanoes. And even planets with 2 suns in their skies. There may be planets that humans would find hospitable, and others on which humans wouldn't dare tread, that could still be home to other types of creatures.
Perhaps the major lesson we've learned so far from looking for planets around other stars is that nature can make a lot more planets than we can dream of.
Finding just one other truly Earth-like planet would hint that Earths are common in the universe. And if Earths are common, then perhaps life too is widespread. But of the over 200 alien planets detected so far, most of them seem utterly hostile to life as we know it.
So far, we've found sort of 3 kinds of worlds. One kind are the planets that are really close to the star that they orbit, and they're totally baked to death. Then there are the ones that are quite far away, and they're pretty cold. And then there are the ones in the highly eccentric orbits, which sometimes get close to the star and sometimes far away. So they're alternately very hot and cold. So far, we definitely haven't found any worlds with jungles and forests. Indeed, we haven't found any worlds that are square smack in the habitable zone where there's liquid water on the surface and other nice conditions.
Our frame of reference for what we consider to be a nice planet is this one. We like it quite a bit. We've got breathable air, it's a pleasant temperature, and there's water. And even in our own solar system, we don't see a lot of planets like that. And right now, the sort of planets we're discovering are kind of monsters. In other words, they're extremes.
So is the Earth, with its rocky surface, oceans, and abundant life, just a planetary wonder with no close kin in the cosmos? The early discoveries of alien planets have yet to answer that question, but they have brought legitimacy to what once seemed like a futile quest. While many believed there had to be other worlds out there in the vastness of the universe, locating them was widely considered beyond the reach of modern science. Only a few decades ago, an astronomer hunting for these so-called extrasolar planets was taken about as seriously as someone searching for UFOs.
The search for planets as it started in the 1980s and 1990s was considered off of the beaten track of standard science.
In the early 80s, astronomer Geoff Marcy's career was going nowhere. His research into the magnetic fields of stars had reached a dead end, and he was beginning to question his own abilities as a scientist.
When I first began thinking about looking for planets, it was in a time in my career when I thought it was over. I thought there was no hope for me as a scientist, and I thought the best shot I had going out in flames was to try an experiment that everybody thought would never work, namely looking for planets around other stars. And most people thought we would never find any planets.
Before Geoff Marcy, his collaborator Paul Butler, and a handful of pioneering astronomers around the globe could begin the search for alien planets, they had to first perfect methods for finding them. Stars are easy to locate using conventional telescopes, but to find a planet takes some ingenuity and patience. Unlike the stars they orbit, planets are small and emit very little light. Even the giant of our solar system, Jupiter, is 1,000 times less massive than the Sun and 10 billion times fainter.
A huge difficulty in taking a picture of a planet around a star is that the planet is extremely, extremely faint compared to the star. The star is so bright, it almost completely obscures the much, much dimmer planet.
Blinded by starlight, planet hunters realized that even if they couldn't see a planet directly, they should still be able to detect its gravitational effect on the star it orbits. A star with no planets should drift smoothly through the sky, while one with planets should exhibit a telltale gravitational wobble.
We often say that planets orbit the sun or other stars, but that's not exactly true. The planets and the stars orbit their common center of mass or center of gravity.
And this center of mass isn't halfway between them. Just like on a seesaw, the more massive object must be closer to the center of mass to bring balance to the system.
So consider the Sun and Jupiter. The Sun is about 1,000 times more massive than Jupiter. So the Sun is here, the fulcrum or balancing point is there, and Jupiter is way out here 1,000 times farther away.
In space, this means that planets trace out large orbits around the center of mass, while stars make much smaller but still detectable orbits.
Here's a hypothetical planet orbiting a star. In fact, they're orbiting their common center of mass. So the planet moves in a relatively large orbit, but the star also moves, but in a much smaller orbit. So the star moves only a little bit, and the planet moves a lot.
I have a somewhat unusual hobby for an astronomer. I'm a belly dancer and fire performer. But it turns out that spinning fire is a great way of simulating the motion of a planet. And the centripetal motion of your fire on a chain is very similar to the motion of a planet under gravity. The light on my wrist represents the star, and the spinning ball of fire around that is a planet. And as you can see, the ball of fire draws out a large circle, and my wrist is drawing out a smaller circle inside it.
It's this tiny wobble of starlight that scientists use to find extrasolar planets. But even this wobble would be undetectable if it wasn't for the Doppler effect, the fact that wavelengths get shorter as the object emitting them moves toward you and longer as it moves away from you.
The Doppler effect is very familiar if you've ever heard a train going by blowing its whistle. So when the train is coming toward you, you hear a high-pitched whistle. And And as the train recedes into the distance away from you, you hear the pitch of the whistle get lower and lower in frequency.
Just like sound waves, light waves appear to shift in frequency as the object emitting them comes toward or away from you. Light from an object moving toward you will look slightly bluer. Light from an object moving away from you will look slightly redder.
When the light waves shift their wavelength toward the blue and toward the red and back toward the blue again as the star wobbles around, the shift is excruciatingly tiny. But it's that difference in the wavelength of the light waves coming at you that is what we measure, and it's what allows us to detect planets around other stars.
Using this Doppler technique, Marcy and Butler spent over a decade patiently studying 120 nearby stars for any sign of a wobble.
I went 11 years without finding a single planet, nothing. And no one was surprised by that. It seemed logical to everybody else that it was a fruitless, frivolous, maybe even lunatic exercise to look for planets of any sort.
But then, in 1995, came the surprise announcement from Swiss astronomers Michel Mayor and Didier Queloz that they had discovered a gas giant planet circling the star 51 Pegasi. Marcy and Butler rushed up to Lick Observatory on Northern California's Mount Hamilton to aim their own telescope at the star and see if they could confirm the Swiss team's results.
Yep, there it is. Looks beautiful. Paul Butler and I were shocked to see that the wobble of the star was precisely as the Swiss had said it was. And I remember driving off Mount Hamilton from Lick Observatory in complete silence, Paul Butler next to me. We knew that the first extrasolar planet had been discovered. It was a very moving, personally moving moment.
Despite the monumental nature of the discovery, this, like all future extrasolar planets, wouldn't get the name of a Greek or Roman god. It would take the astronomical catalog name of its parent star, 51 Pegasi, and add to it a lowercase b. In this standard nomenclature, if a second planet was found around the same star, it would get a lowercase c, and so on through the alphabet. Its name was the only thing unassuming about 51 Pegasi b. The discovery shook the foundations of our understanding of planets. In 1995, astrophysicist Alan Boss was asked to review a paper announcing the discovery by two Swiss astronomers of the first planet orbiting an alien sun.
Reviewing this paper caused me a fair number of sleepless nights because it was pretty stunning what they had found.
Stunning because the Swiss claimed to have found a Jupiter-like planet. But where Jupiter orbits the sun in 12 years, this planet zipped around its star in only 4 days.
And that also meant that the planet had to be much, much closer to its central star, roughly 100 times closer than Jupiter is. And that just was hard to understand.
Jupiter orbits the sun at a comfortable distance of around 500 million miles. 51 Pegasi b is more like 5 million miles from its star. If it were dropped into our own solar system, this alien planet would orbit much closer to the sun than Mercury, our innermost planet.
Being so close to the star means that the planet is being literally fried. The radiation from the star is incredible compared to what we experience here on Earth, relatively far from our sun. So this was a completely unexpected discovery.
It was a planet that could not have formed there. Astronomers knew it didn't belong there. In the same way that if we found a giant redwood in the middle of Central Park, we would know that it didn't belong there. You'd have to ask yourself, how did it get there? And that's what astronomers were asking themselves about these giant planets that they were finding.
51 Pegasi b wasn't just a freak of nature. It was the first of dozens of so-called roasters or hot Jupiters to be discovered in seemingly impossible close-in orbits. Impossible because the accepted theory for how gas planets form suggests that rock and ice in a disk surrounding a young star coalesces into a solid core that then accretes gas, growing larger and larger until it has cleared out all the planet-forming material in its area. This process can only occur at a distance far enough from the star where it's cold enough for ice to exist.
You can't form something that massive that close into its star. It needs to form past the snow line where ice can form. And in our solar system, that's about where Jupiter is, about 5 times further out from the sun than the Earth.
So how could a gas giant planet like 51 Pegasi b form so scorchingly close to its star?
It was one of these things where I woke up in the middle of the night, and one night I said to myself, maybe what this means is that this object had to have migrated inwards from where it originally formed.
We now, I think, have an understanding that planet formation is an almost chaotic process, a sort of roll of the dice, with many planetesimals, wannabe planets, forming, building up, and a competition, a sort of gravitational musical chairs takes place, in which the planets compete for their own space.
In this competition, some planets are flung out of the solar system, and some are tossed toward the center. It's believed some planets crash and burn on their parent star, while others survive in a close but stable orbit. These survivors are the hot Jupiters. The discovery of the hot Jupiter circling 51 Pegasi sent planet hunters Jeff Marcy and Paul Butler back to analyze the data they'd been collecting for the past decade. Their team had been looking for the expected long-term wobbles caused by a giant planet.
We ourselves suddenly realized we should analyze our data in a slightly different way, look for the shorter period planets, not just planets that take a long time to go around their star. And that led us to discover within existing data all of these planets that had been buried there for years. I remember the day like it was yesterday, December 30th, 1995. And at 8 a.m. the phone rings. I pick it up, it's Paul Butler, my ace collaborator for 20 years now. And Paul just said, "Jeff, come over here." So of course I immediately got in my car. I drove right to this very office right here where I'm sitting now in Campbell Hall at UC Berkeley. And he showed me his computer screen. And there on that screen was the unmistakable graph of the wobble of the star 70 Virginis, going up and down the star, wobbling to and fro, exactly as we had imagined a planet signature would look in our data. So that was the moment, with both of our eyes open this wide, that we knew we had discovered our first planet, the second planet ever discovered.
70 Virginis b is 59 light-years from Earth in the constellation Virgo. With a mass at least 7 times larger than Jupiter, this world immediately claimed the title as the planetary heavyweight of the known universe.
Here, right before our eyes, essentially, is a planet 7, maybe 10 times bigger than our own Jupiter, telling us immediately that, yes, nature does make planets even bigger than the largest ones we have here in the solar system.
Rather than a hot Jupiter, this planet was the first of a new class of alien worlds called eccentric giants, because of their eccentric or elongated orbits. 70 Virginis b swings out as far as 63 million miles from its star, and passes as close as 27 million miles.
The frightening aspect of the planet around 70 Virginis is that we all grew up in kindergarten learning that planets go around the sun in nearly circular orbits. So what in the world is a planet doing going around its star in one of these elongated, wacky orbits?
Already, the first 2 planets discovered around alien suns were challenging our view of how planets should behave. Further discoveries over the next decade would show that eccentric orbits are common in the universe, while the circular orbits of our solar system seem to be rare.
It's embarrassing, frankly, when you think about how we humans imagined planets would orbit other stars, how common they would be, what properties they would have. Guess what? We imagined that those planets would look just like the planets that orbit our sun. Extraordinarily nearsighted in retrospect, and for a scientist I find it embarrassing that I was a party to this. But in fact what we've learned is that planets around other stars are remarkably different from the representatives we have around our sun.
The planet hunting revolution that began in the 1990s has also obliterated any notion that planets are rare in the universe. With an ever-growing catalog of alien planets, astronomers are now trying to learn all they can about the more than 200 worlds they've already discovered. The Doppler technique used by Geoff Marcy and other astronomers tells them the mass of the planet they found, but it doesn't tell them the size. To figure out just how big an alien planet is requires a bit of good luck. The orbit of the planet has to be aligned in such a way that from Earth we can see it pass directly in front of its star. This is called transiting. By measuring how much the starlight dims during this transit, astronomers can actually determine the size of the planet. In the fall of 2007, astronomers were watching when a hot Jupiter called Trace 4 transited its star. The planet was about the same mass as Jupiter, and therefore should have been roughly the same size. But astronomers were in for a surprise. Trace 4 turned out to be almost twice as big as Jupiter. It was, in fact, the largest planet ever discovered, sort of a Jupiter on steroids.
Some of these extrasolar planets are really fluffy. They're really expanded in size. And we think that the reason why that's happening is because they have an internal source of heat, which is raising the pressure inside the planet and causing it to expand. That's very similar to a steam boiler on a steam train. In a steam boiler, you have water, which is being heated by a heat source. That water is turning to steam. The pressure is increasing, and that's causing the piston of the boiler to move out, to expand. If you didn't have the gas's ability to expand, the planets wouldn't inflate, steam trains wouldn't work, we wouldn't be climbing up this mountain.
While internal heating is the likely cause of the so-called fluffy Jupiters, something much stranger is happening on this alien world. In the field of extrasolar planets, it seems each new discovery creates a brand new world of scientific intrigue. At the University of Arizona, planetary scientist Adam Schoeman ponders the weather on other planets. Recently, Schoeman helped generate the first ever forecast for a planet beyond our solar system. And what he found was weather truly befitting an alien world.
We think that the winds are probably about 6,000 miles per hour, possibly even more. This is huge compared to the wind speed on any planet in our solar system.
This is HD 189733b. It's a hot Jupiter, more than 60 light years from Earth, that races around its sun-like star in a little over 2 days, at a distance of only 3 million miles. How is it possible to divine the weather on a planet 370 trillion miles away? First, you have to take the planet's temperature. Scientists knew that since the planet orbits so close to its star, it would be tidally locked, a gravitational effect that would cause it to show the same face to the star at all times. One side would always be bathed in the burning hot light of the alien sun, while the other would be cloaked in perpetual darkness.
If there was no wind on these planets, then that would mean that the day side would then be very, very hot, and the night side would be very, very cold.
In the spring of 2007, scientists used the Spitzer Space Telescope, which sees in infrared wavelengths associated with heat, to generate a crude map of the temperature on both the day and night side of the planet. You are actually looking at the first map of any kind made of an alien world. What the map shows is that the day side of the planet is roasting at an otherworldly 1,500 degrees Fahrenheit. No surprise, given how close the planet orbits to its star. What was surprising was how hot the night side of the planet turned out to be. Despite being in total darkness, it swelters at around 1,000 degrees. Clearly, something was distributing heat throughout the planet's atmosphere, carrying thermal energy from the day side clear around the other side of the planet. From his knowledge of weather in our own solar system, Schoeman knew what the culprit was. He ran the numbers, and that's when he figured out that this alien world had jet streams of unprecedented magnitude. Their 6,000 mile per hour winds dwarf anything in our own solar system.
Earth actually has the slowest speeds of any planet in our solar system, with a typical speed of about 20 miles per hour. The gas giants in our solar system actually have somewhat faster winds than the Earth, simply because there's no surface to have friction to slow down the winds. On Jupiter and Saturn, for example, the winds are a few hundred miles per hour. So they're still about almost a factor of 10 lower than on these hot Jupiters.
The weather on hot Jupiters may be extreme, but the forecast for another class of alien planets, the eccentric giants, is tailor-made for a disaster movie. This is HD 80606b, a gas giant planet located roughly 200 light-years from Earth, orbiting a star in the constellation Ursa Major. A year on this bizarre world lasts 111 days, and it has the most eccentric orbit of any known planet. With its nearly circular orbit, Earth's distance from the Sun changes relatively little throughout the year, varying by only about 4 million miles. But during its year, HD 80606b comes as close as 3 million miles to its Sun, and as far as 78 million, a difference of 75 million miles.
This crazy orbit leads to completely crazy weather. The planet heats up by hundreds and hundreds of degrees in a matter of a few hours, and that drives just absolutely tremendous storms.
As the planet swings in close to its star, the alien sun looms ever larger in the sky.
And so you get a huge amount of heating on one side of the planet. The other side of the planet is in the night. And what that does is it drives an intense storm. It's basically a shock wave around both sides of the planet that is moving roughly at the speed of a supersonic jet.
This fiery hurricane rips around the planet in only 12 hours. As the shock wave slowly dies down, the superheated atmosphere churns into a giant vortex that engulfs an entire hemisphere, a sort of greater red spot. As the planet moves away from the heat of its star, the storm gradually loses energy and intensity. But on this eccentric giant, the calm never lasts for long. Every 111 days, the shockwave is reignited and the violent cycle begins anew.
It's much stranger than anything that we have in our own solar system. If you were there, you would be incinerated immediately before you had a chance to really sort of groove on your surroundings.
The universe seems adept at creating strange worlds, even in the most unlikely of places. This is a pulsar, a rapidly spinning variety of an exotic stellar object called a neutron star. Neutron stars are the remnants left behind after a massive star explodes in a supernova. No one expected to find planets circling in such a treacherous cosmic neighborhood.
Never in my wildest dreams did I think we would ever find planets orbiting a neutron star, a pulsar. I mean, after all, neutron stars are formed as a result of supernova explosions where the star just blows up. So certainly any planets that might have been there to begin with would have been blown away.
And yet, in the early 1990s, astronomers discovered 2 rocky planets around a pulsar 7,000 trillion miles from Earth. Their discovery, in fact, predates 51 Pegasi b, making them technically the first alien worlds ever detected. But since they orbit such strange stars, many astronomers consider pulsar planets to be in a category of their own.
The pulsar planets were very interesting. They're actually very low in mass and more similar to the Earth's mass. They form an interesting exotic classification or family of planets, but it's by no means the mainstream.
While most planets are believed to have formed out of the same disk of gas and dust as their parent stars, clearly these pulsar planets formed a different way.
The planets that have been found must have formed after the supernova explosion. And that's really bizarre because we would think that all of the material was blown away, but apparently some of that debris must have somehow been in a disk, and parts of that disk coalesced into planets. But that's extremely surprising. I don't know that anyone really understands that process yet.
Although the pulsar planets are believed to have rocky surfaces, it's unlikely they would be a platform for life, and any visit by humans would be short-lived. As the pulsar rotates, it emits well-focused beams of charged particles from its poles, creating a rotating spotlight of horrific radiation.
Standing on a pulsar planet would be a very dangerous proposition. There would be high-energy radiation all around you, just an onslaught of particles and waves. And the radiation field would be so strong that it would probably destroy your living tissue, and it would certainly cause cancer and mutations very quickly. But it would probably kill you. If you were really unlucky, or lucky, I suppose, if you're going to die anyway, might as well die in a spectacular way, you would be in the beam of the pulsar. So every rotation, the beam would flash past you, and you would see this incredibly bright beacon, like a lighthouse really close to you, just flashing in your face. It would not be a very hospitable environment, no way.
While the pulsar planets might not be nice places to visit, they have taught us something fundamental about planet formation in the universe.
These planets, weird planets around a neutron star, have taught us that planetary formation appears to be relatively easy. Gravity appears to like to pull stuff together when there's enough stuff in a given region.
If nature is so good at making planets, even under difficult circumstances, then the odds are fairly high that the universe is full of planets, and that somewhere out there in the cosmos, other Earths are waiting to be discovered. But if that's the case, then where are the Earths? Why haven't we found them yet?
The first planets that were found in the late 1990s were massive planets, 300 times the mass of our Earth. And it's really not a surprise that we found the most massive ones first. Like the giant redwood trees behind me, they were the easiest to see from the enormous distances that we were looking. So when we find stars where we say, there's just one single massive planet, one giant redwood, that's almost certain to not be true. There's almost certainly a forest of planets and asteroids and comets also orbiting that star.
As astronomers continue to scrutinize alien solar systems, they are edging ever closer to finding Earth-like planets. This is Gliese 436b. It's a world roughly 20 times the mass of Earth, similar in mass and size to Neptune. It orbits a star 30 light-years away in the constellation Leo.
I'm so excited about Gliese 436, I'm almost jumping out of my clothes. It's the most important discovery since 51 Pegasi, maybe even more important.
What has Jeff Marcy so excited is that this planet was found to have a density of 2.1 grams per cubic centimeter.
What does that mean? It's a spectacular number, because every school child knows that the density of water is 1 gram per cubic centimeter. And we also know that rocks that you pick up on the street, the density of our Earth, for example, as a rock, is about 5 grams per cubic centimeter. And therefore this planet, around 436, is composed of a mixture of rock and water.
A planet made of rock and water sounds tantalizingly Earth-like, but Gliese 436b has so much water there would be no land masses exposed at all. And you wouldn't want to take a swim in the oceans of this watery alien world. There may be a layer of liquid water on the surface, but below that, things begin to get a little weird.
There's so much water that the sheer gravitational force of the water molecules pressing down toward the center will crush the water so tightly that the water molecules are almost touching each other. It's a very odd type of water. In fact, we call it ice, even though it's not cold, because the water molecules will be arranged in a structure like ice, but only due to its high pressure.
Clearly, Gliese 436b isn't quite an Earth-like planet. But what about this alien world? What would make an alien planet truly Earth-like? It should be made primarily of rock, with enough water for oceans, but not so much water that the land masses are completely submerged. It would also have to be in its star's habitable zone,
The typical idea for a habitable zone is the range of distances from a star where an Earth-like planet could have liquid water at its surface. The idea would be that if you took Earth and pushed it in too far, the oceans would all boil away, and that's bad for life. Or if you took the Earth and pushed it out too far, the oceans would all freeze, and that's bad for life.
In our own solar system, the habitable zone ranges from Mars's orbit into as close as where Venus orbits. But the habitable zone in alien solar systems varies, depending on how hot the star is. Currently, our best hope for finding habitable Earth-like planets is to look around cool, dim stars called red dwarfs or M dwarfs.
The M dwarfs themselves are very special stars. So our sun might be a 100-watt light bulb. An M dwarf is perhaps a 10-watt light bulb. And so what that means is that to stay warm enough so that you have liquid water, not ice, but still not too hot, you move the planet in much closer. And those close planets are easier for us to detect with our technique because they tug on the star more.
One of these M dwarfs, called Gliese 876, has been found to have at least 3 planets orbiting it. 2 of them are gas giants, but the third, Gliese 876d, is one of the smallest planets discovered so far, at roughly 6 or 7 times the mass of the Earth. It's also just on the edge of its star's habitable zone.
The planet orbits in just 1.9 days around its host star, but because the host star is so low in luminosity, it puts it on the edge of what you might imagine the habitable zone to be. There could be some region, a ring around the planet towards the back side, where the temperature is actually just right for liquid water to exist.
When it was first discovered, scientists hailed this planet as the first of the super-Earths.
7 times the mass of the Earth sounds so close to the size of our Earth that you wonder whether or not it's a rocky planet, maybe with a thick atmosphere.
But today, the experts are unsure whether this is a large rocky planet at all. Like Gliese 436b, it may be completely covered in an ocean of super-dense water.
Well, to call it a super-Earth is to suggest that we've found a planet that's a close cousin of our Earth. I would now rather think of it as a distant cousin, not unrelated to our Earth, but far enough away, indeed more like Neptune in our own solar system, that has a big rocky core, but surrounded by a big envelope of water.
So the race continues to discover the first truly Earth-like planet. At the University of Arizona, astronomer Laird Close is hoping to capture the first picture of an alien Earth. But to do that will take a giant leap in telescope technology. Here at the Steward Observatory Mirror Lab, in a cavernous space underneath the bleachers of the university's football stadium, engineers are working on the next generation of super telescopes.
This is the largest mirror that's ever been made. This mirror is 8.4 meters across, but it's just 1/7 of the size that's needed for the giant Magellan telescope. And together, when combined with 7 other mirrors like it for the Giant Magellan Telescope, we will be able to actually directly image extrasolar planets and maybe even Earth-like planets around alien suns.
Scheduled for completion in 2016, this telescope will be able to make images up to 10 times sharper than the Hubble Space Telescope. NASA and the European Space Agency are also developing several missions that will use space-based telescopes to search the stars for our planetary kin.
This will be incredibly exciting for humankind to know whether or not around those little points of light that we see in the night sky, whether there's Earth-like planets tied in orbit around those stars.
As technology improves, we're going to be able to find planets that look much more like the Earth. Planets that perhaps have life on them, and maybe even planets that have forests and steam trains.
The astronomers who have dedicated their lives to this quest all believe it's only a matter of time before we find the first truly Earth-like planet.
The most exciting thing I can tell you is that we are now routinely discovering, commonly discovering planets that are a mere 5 or 10 times the mass of our Earth. We're not quite to the point where we're finding Earths, and that's where we really want to be. but we're finding planets that are ever so close to our home planet.
So when we actually do cross that final threshold and do find evidence that there's a habitable planet out there, this is going to be quite an epical event for humanity.
People should not worry too much yet that we haven't found any Earth-like planets because, well, a lot of effort's going into it right now, and I think it will be done in the next 10 years. Yeah, stay tuned.
In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. Are there planets beyond our solar system? It's a question few had dared to probe.
The origin of hunting for planets started really from the lunatic fringe of science.
Now hundreds of these exotic worlds have been found. Could any of them be home to alien life?
Right now, the sort of planets we're discovering are kind of monsters.
You would be incinerated immediately before you had a chance to really sort of groove on your surroundings.
But some planets hold more promise.
I'm so excited about Gliese 436, I'm almost jumping out of my clothes.
Could we be on the verge of finding another Earth?
We still don't know whether our Earth is a commonly occurring planet or a 1 in a billion freak.
Cutting-edge science, strange worlds, and wild weather as we travel the universe in search of alien planets. Lurking in the constellation Pegasus, 50 light-years from Earth, is a monstrous planet. A superheated gas giant almost as massive as Jupiter, whipping around its star in a little over 4 days. It's called 51 Pegasi b, and in 1995, it became the first planet detected orbiting an alien sun. It was a landmark discovery, but just a stepping stone on an even greater quest to find a planet that looks more like our own. The ultimate but elusive goal for astronomers is to find another Earth.
What we're after is the appreciation of where our Earth fits in the grand context of our universe, and we'd love to be able to find other Earths. But Earths are so undetectable, little chunks of rock that don't emit much light.
How common might Earth-like planets be in the universe? Even if only 1% of all stars were circled by a planet like our own, that would still mean there are billions of other Earths waiting to be discovered.
We are almost sure that rocky Earth-like planets exist in abundance out there. But how Earth-like? There are still open questions about the uniqueness of our Earth. And we don't know whether our Earth is unusual or not. It's an extremely profound and, I think, disturbing question.
In the realm of alien planets, there's a wide range of imaginable worlds. We might find ocean worlds, completely covered in water. Frigid ice planets. Mars-like worlds, but perhaps with thick atmospheres, fed by massive active volcanoes. And even planets with 2 suns in their skies. There may be planets that humans would find hospitable, and others on which humans wouldn't dare tread, that could still be home to other types of creatures.
Perhaps the major lesson we've learned so far from looking for planets around other stars is that nature can make a lot more planets than we can dream of.
Finding just one other truly Earth-like planet would hint that Earths are common in the universe. And if Earths are common, then perhaps life too is widespread. But of the over 200 alien planets detected so far, most of them seem utterly hostile to life as we know it.
So far, we've found sort of 3 kinds of worlds. One kind are the planets that are really close to the star that they orbit, and they're totally baked to death. Then there are the ones that are quite far away, and they're pretty cold. And then there are the ones in the highly eccentric orbits, which sometimes get close to the star and sometimes far away. So they're alternately very hot and cold. So far, we definitely haven't found any worlds with jungles and forests. Indeed, we haven't found any worlds that are square smack in the habitable zone where there's liquid water on the surface and other nice conditions.
Our frame of reference for what we consider to be a nice planet is this one. We like it quite a bit. We've got breathable air, it's a pleasant temperature, and there's water. And even in our own solar system, we don't see a lot of planets like that. And right now, the sort of planets we're discovering are kind of monsters. In other words, they're extremes.
So is the Earth, with its rocky surface, oceans, and abundant life, just a planetary wonder with no close kin in the cosmos? The early discoveries of alien planets have yet to answer that question, but they have brought legitimacy to what once seemed like a futile quest. While many believed there had to be other worlds out there in the vastness of the universe, locating them was widely considered beyond the reach of modern science. Only a few decades ago, an astronomer hunting for these so-called extrasolar planets was taken about as seriously as someone searching for UFOs.
The search for planets as it started in the 1980s and 1990s was considered off of the beaten track of standard science.
In the early 80s, astronomer Geoff Marcy's career was going nowhere. His research into the magnetic fields of stars had reached a dead end, and he was beginning to question his own abilities as a scientist.
When I first began thinking about looking for planets, it was in a time in my career when I thought it was over. I thought there was no hope for me as a scientist, and I thought the best shot I had going out in flames was to try an experiment that everybody thought would never work, namely looking for planets around other stars. And most people thought we would never find any planets.
Before Geoff Marcy, his collaborator Paul Butler, and a handful of pioneering astronomers around the globe could begin the search for alien planets, they had to first perfect methods